Good morning, students. I welcome all of you for today's session. So, let us continue with the fourth module and we will move towards statistical process control today. Coming to the definition of statistics, you might have studied this subject in your high school days. Statistics, it's a science of collecting, organizing, analyzing, and interpreting data in order to make a decision. So usually what type of data we are collecting, it is numerical in nature. Then what is process? Already we have discussed it, but let us once again describe it. It is a series of actions or steps taken in combination of material, people, equipment and procedures to achieve a particular product. Contents, topics to be discussed today. Let us discuss 7 quality control tools. First one, check sheets. Second one, stratification. Third one, Perito Chart. Fourth one, cause and effect diagram. Fifth one, histogram. Sixth one, control chart. And last one, scatter diagram. Except stratification, all are there for your syllabus. But anyway, it is also an important quality control tool. Let us discuss all the 7 quality control tools. First one, check sheets. So it is a sheet for checking purpose only counting purpose. So it is a sheet for checking or counting. You can see here on daily basis how many items have been arrived or departed. It is counted on daily basis here. What is the purpose of check sheet? It is a tool for collecting and organizing measured or counted data. And data collected can be used as input data for other quality tools. And data collections are based on answering the questions of what, why, when, where, who, and how. Especially questionnaire type data: what, why, when, where, who, and how. This data will help to answer the questions like this. Why check sheet is needed? Because it focuses on factual approach. What is actually the fact for decision making? Without check sheet, there is no way to identify problems, continuous improvement, and ensure to meet the customer requirement. Hence, check sheet is needed. So to identify the problems and hence to take continuous improvement, we need check sheets. When to use a check sheet? To collect data repeatedly by the same person or at the same location. So whenever we need to collect data from the same person or location. So this type of tool is used whenever we need to collect data repeatedly, like hourly base, daily base. Second one, to collect data on patterns of events, problems, defects, defect location, and defect causes. So to identify the pattern of events, problems, defects, defect location. So whether it is occurring at the same place, to collect data, it's used. Benefit: collect data in a systematic and organized manner. So data collected is a systematic and organized manner to determine source of the problem. So where the problem originated or arise, to determine it is used. To facilitate or simplify classification of data, and it also helps to ensure successful analysis of the problem. Coming to the second quality control tool, this is stratification. So this quality control is used especially to make classifications or divisions. You can see left side and right side, there are two diagrams. Left side, which is a stratified data of human resource or people, leaders, managers, doers. Right side is data of machine. So classification of machines may be based on their activities, machine 1, 2, 3, like this. Definition of the stratification, as I said, it is a system of formation of layers, classes or categories. Data collected using check sheets need to be meaningfully classified. Such classification helps in gaining preliminary understanding of relevance and dispersion of data so that further analysis can be planned to obtain a meaningful output. Meaningful classification of data is called stratification. When to use stratification? When data come from several sources or conditions such as shifts, days of the week, suppliers or population groups. When data analysis may require separating different sources or conditions. For example, variation of the object in different machines, in three different machines, age stratification of two different country, division of society. So whenever we need to categorize or make class, we use to we have to make use of a stratification tool. Next, third one, it is also a very important quality control tool, Pareto chart. Pareto chart. See, the data is distributed in a bar form here. Left side you can see the higher level bars, and right side the lower level bars. See, it's a data collected revenue by the customers. So x-axis represent customers, y-axis represent percentage of revenue, and the right side of the y-axis, extreme right, that is percentage of the revenue. It is cumulative percentage of the revenue. So there are n number of customers, A, B, C, D, E, say up to P, Q. Okay, and the revenue, percentage of revenue from individual customer is represented in this chart. First one, A, say he is representing 30, he is contributing 30% of the revenue. So second one, B, is he is representing around 22 percentage. Like that it goes. So we have to make chart in a descending order so that we will come to know that who is contributing more. See, first, if you analyze the chart or of representing, we will come to know that first four, they are contributing 80 percentage of the revenue out of all the customers. Okay, so it is represented cumulatively. First one 30, second 22, so cumulative is 52. Third one again 15 percentage, so total 67. Like that, fourth one it will become 81. So first only 4 persons are contributing 81 percentage. So Pareto chart is used to make the important and unimportant distribution of the data. Wilfred Pareto, he was an Italian economist, developed this principle. 20 percentage of the population has 80 percentage of the wealth. So to identify the 20 percentage of the vital or important population, we need to make use of the Pareto chart. Juran used the term vital, that is significant few, trivial or insignificant many. Vital few and trivial many. Vital means important. There are very few important people or the data, and there are many insignificant data. So to know who are contributing more, we need to use Pareto chart. And Duran noted that 20 percentage of the quality problems caused 80 percentage of the dollar loss. The purpose of a Pareto diagram is to separate the significant aspects of a problem from the trivial ones. Trivial means the insignificant ones. Fourth one, quality control tool, cause and effect diagram, and popularly known as fishbone diagram. It's a very well popularly used diagram you can see here the structure of the diagram is like it bone of the fish, so it's called fishbone diagram also. And we are analyzing the cause and effect. After effect, we need to identify the cause. So in that purpose we need to use this diagram. See, in industry, there will be process. Finally, we'll get output. So for output, it will be processed. To process, there may be many inputs like machines, methods, materials, manpower, environment, measurement. So these are different inputs for a processing or to get the product. If anything happens or we are facing some problems, we need to find out the cause, finally root cause of the problems. So if it is a method, where are we not using the proper methods, which method is not appropriate. If machines, which machine is not working well, in machine which part is not working well. So it goes deep into the system. In the same way, if it is from the manpower or human errors, what type of error, whether inexperienced person or experienced person, or he is not using the tools properly, what exactly causing the problem. Similarly, in case of materials, whether the materials, raw materials taken are good or not, and measurement also, whether the measuring equipments are correct or not, whether calibration has been done or not, and environment, whether safe practices are adopted or not, like this. So all the inputs are analyzed here to the to find out the root cause of the problem. So benefits of the fishbone diagram. Fishbone diagram, it breaks down or make pieces to find the root cause. We will break the problem into many pieces so that we will identify the root cause. It encourages team, more work or participation we can find out here. Common understanding of factors causing the problem. It's a roadmap to verify picture of the process, how the process is happening. It's a roadmap. It follows brainstorming relationship. So many thinking process will go on this. It indicates possible causes of variation. It increases process knowledge, and the diagram demonstrates knowledge of the problem solving team. So there are many benefits of the fishbone diagram. It can be used to find out the root cause of the problem. Fifth tool, histogram. So you can see the bars are distributed on the chart, in the chart. So it is a curve. Ultimately, the bars are analyzed in a curve way, and there will be upper and a lower limit. There will be upper and lower limit, and this should be in between the upper and lower limit. So where this, what is histogram and where it is used? Let us see. Histograms are graphs of distribution of data designed to show centering, dispersion, and shape relative frequency of the data. They are used to understand each process capable. So this histogram diagram is used to determine whether uh, process is capable to do the given work or not. If the process is in between the control limits, see, right side there is a upper specification limit, left side there is a lower specification limit. So if this bar distributed data is in between this, then it is capable. Otherwise it is out of control, then it will the process is not capable to do the work. What is process capability? It is the ability of a process to meet customer requirements. When to use this histogram? When the data are numerical and want to see the shape of data's distribution, when analyzing whether a process can meet the customer requirement, and analyzing the output from a supplier's process and to see the process change has occurred from one time period to another. So in these situations, histogram are used. So especially whether it is capable to do the work or not, this histogram is used. Interpretation of the histogram, you can see there are three curves here. First one, it's actually the curve, the bell curve is centrally tendenced. So both side we can see equal distribution of the data or in the form of bars. The second one, it's lightly it's representing a right side. So the right side data is more distributed. Third one, it is a left side. It's a left side distribution of the data. And last one, you can see the one small bar which is the outside of the continuous bars. So first one, it is centrally tendency is there, we can interpret that. Second one, right side skew. Third one, left side skew. And last one, we can say it's outliers. The isolated bar at the ends of the identify outliers. The data values are far away from the other data values, which can strongly affect our results. So benefits of histogram. It allows you to understand at a glance the variation that exists in the process. The shape of the histogram will show process behavior. The shape and size of the dispersion will help to identify hidden sources of the variation. It is used to determine the capability of the process and it is a starting point for the improvement process. Coming to the sixth, quality control, it is a very important tool, and in the next session also we will discuss on control charts only. Sixth one is control charts. The control chart is to study how a process changes over a time. A control chart always has a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data. When to use a control chart? When controlling ongoing processes by finding and correcting problems as they occur, when predicting the expected range of outcomes from a process, when determining whether a process is stable or not, when analyzing patterns of process variation from special causes or common causes. So control charts, there will be again upper control limit and lower control limit. So, what is the benefit of this control charts? To predict process out of control and out of specification limits, distinguish between specific identifiable causes of variation. It can be used for a statistical process control. Similarly, control charts serve as the early warning detection system, telling you that now is the time to go in and make a change. After analyzing a control chart, operators need to determine whether to do something or do nothing. So, always the operator should monitor the control chart. Again, the data should be in between the upper line and the lower line, so that the process is moving continuously and there is a stability. We will discuss the next session in detail with this control charts. The last and the seventh one quality control tool is scatter diagram. See, since the data is scattered here, it's called scatter diagram. To identify the correlations between a quality characteristics and a factor that might be driving it. So to identify the correlation between two variables, this scatter diagram is used. It shows the correlation between two variables in a process. These variables could be critical to quality characteristics. So to identify the critical to quality characteristics, we have to use or the scatter diagram is used. See, in the diagram for the ice cream sales, again the sales versus the temperature. So is there any relation between the sales and the temperature of the ice cream system is considered? Similarly, in the second one, uh, price of peaches. So, price and the number. Is there the price and quantity? The correlation between the quantity and the price is analyzed through this scatter diagram. Benefits of scatter diagram: it shows the relations between the two variables. It is the best method to show you a non-linear pattern. The range of data flow, that is maximum and minimum value, it can be easily determined. Last one, observation and reading are very straightforward and direct. By just seeing the data, you can see whether there is a correlation between them or not. If they are too much close, then that means they are correlated. If the scatter diagram, the distributed data is away from each other, then it shows that there is not much correlation between the two variables. So these are all the 7 quality control tools. uh, I hope you got a very well understanding of today's session, and please, all of you, attend and participate at today's quiz. It's a must, and it will be considered for your IMRs also. And I and Rahul sir will be there for your any type of your queries. Thank you very much.